Okay. Welcome to Introduction to like Basic Chemistry. I don't know why it keeps switching. Okay. What? Okay, anyways, welcome. These are the units that we will be going throughout this course. It should cover grade level chemistry and some honors chemistry topics. I'm not sure what the curriculum is at like all you guys' different schools, but this should help with like understanding a lot of the like concepts that you'll be using in honors chemistry, AP chemistry, and maybe some further ones. So we're going to be going through the periodic table and terminology today with some introduction to the units, exponents, and significant figures. Then later on, we'll be learning about basic periodic trends, atoms, molecules, and ions. We'll be balancing equations. We'll do stoichiometry, and then atomic structure and bonding, gases, liquids, and solids, basic properties, and then periodic trends part 2, intro to energy, thermochemistry, kinetics, all that good stuff, and then intro to acids and bases. Whoops. Anyways, today's lesson, I will be introducing you guys to chemistry. I'll give you guys some basic terminology to know. With the atom, the periodic table, and I'll give you an introduction to some chemistry, like number rules that you have to know. It's probably the most annoying part, but it's really easy. Don't worry. Of course, I strongly recommend you guys to take notes just because it helps with like memory and understanding. Of course, it's not required, and I will most likely put like the slides on Google Classroom, but I might say things that aren't on the slides that you might want to write down, so it'd be cool for you to do that. So basically, what is chemistry? It's the study of how things react with other things and why things react with other things and what happens when they react with other things. But chemistry is about all of this stuff, but it's also about looking into those, quote, things. More specifically, it's about how atoms, molecules, elements, and compounds react with each other, why they react with each other, and what happens when they react with each other. That's basically what we'll be learning about throughout this course. But today I'll be giving you an introduction about it. So here you see atoms, molecules, elements, and compounds. So those are like the basic forms of matter that we'll be looking at throughout this course. So atoms. Atoms represent elements and they make up molecules. Like, for example, the oxygen atom, which is represented by the letter O. I'll talk more about it later and why it's very important to us and like what parts of the atom we'll be studying and like how different atoms of different elements look different. Molecules are like a group of combined atoms that represent combined elements. So like when you take two atoms and put them together, that's a molecule. For example, the carbon dioxide molecule is made up of carbon and oxygen atoms. So when you take those two atoms and combine them, it's a molecule. Okay. I'm gonna check the chat real quick. I don't know how. Okay. Okay. So now we're going to talk about elements. Elements are pure substances that are made up of or represented by a specific type of atom. For example, carbon is an element. Oxygen is an element. Nitrogen is an element. Those are all elements. They're basically going to be like the building blocks of like the compounds that we make. Speaking of compounds are substances that are made up of or represented by molecules, and it's the result of two elements together. So I don't know if this makes sense to you, but like atoms represent elements and molecules represent compounds, right? So atoms together represent molecules. So elements together represent compounds. For example, water. Water is a compound because it's like the hydrogen element and the oxygen element combined. It's also a molecule because it's the hydrogen atom and the oxygen atom combined. So compounds are like parallel to molecules, and elements are parallel to atoms. I know this is all very confusing and they probably sound the same to you, but like once we work with these terms more, they'll become more and more familiar. You guys good with that? Okay. So in easier words, atoms make up elements and elements form compounds. Atoms form molecules and molecules make up compounds. So like here the words make up and form are very important. Okay, this probably confuses you a bit more, but like just know that atoms and elements are parallel and molecules and compounds are parallel. That's basically it. Okay, so now we're going to talk about the atom. As we mentioned before, it is the smallest thing possible. Like it makes up molecules, it represents elements, all that good stuff. So the atom is actually the smallest form, the smallest unit of an element that can retain all the properties of an element. It originates from a Greek term, which means not able to be like divided or cut because it's the smallest particle, right? I mean, I'm pretty sure recently they discovered a way to like split atoms and they made quarks, but like that's into physics and we don't need to know that. But it's the smallest studyable part of an element. So as I mentioned earlier, the atom is the smallest component of an element studyable. There is only one type of atom per element. There will be variations to atoms that we'll learn later, like ions and like other things. Atoms of different elements won't be the same because each element has its own unique atom. Like they all look different from each other. But atoms represent elements and make up molecules, like I said earlier. Yeah, so we're going to talk about the composition of an atom. It's made up of three major or three big particles that you have to know about. It's made up of protons, neutrons, and electrons. Protons, you probably know this, they're positively charged. Neutrons they have no charge, and electrons are negatively charged. Protons and neutrons are located in the nucleus, which is right here. Oh, whoops. Right here. I don't know if you can see the cursor, but wait. They're like in the middle, that little pile of blue and yellow stuff. Those are where protons and neutrons are located, and that's called the nucleus. And then all these things around it, like the big ovular shaped red lines, those are electron shells or energy levels. There's many different names for them, but that's basically where electrons are located. They just float around the nucleus in these little orbitals. And there's actually a lot of empty space in between, as you can see, all that white area there. But like, I say lots of empty space because like when you zoom in, it looks like there's a lot of space, but then in reality, like you can't even see an atom, so it's not really that much space in between. Yeah. So that basically sums up our atoms talk. If you want me to review something, I can because I know it's very confusing. I can try and explain it more later, or you can just ask me if you have any more questions. So now we're going to be talking about the periodic table of elements, this gorgeous thing that you've probably heard about. A lot of people are worried about memorizing it. That is definitely not required. I don't know why that's a thing. You just have to be familiar with it and like be able to read it, which I will be teaching you guys later. But for now, The terminology here, you have to know what the groups are. So they're the columns. On the top, you can see there's group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13, 14, 15, 16, 17, and 18. Those are the groups. There's 18 groups on the periodic table, and they each have a specific name. Here you can see they're labeled on the top, so you can screenshot this if you want the names for the groups. Or I'm going to put the slide on Google Classroom anyways, so you can also just save the picture from there. But I have the names here if you want them, but we can go back to the picture. Group 1 is alkali metals, so that contains hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. You don't have to know half of these. The second group is alkaline earth metals. That's like the darkish orange column. It starts with beryllium, it goes to magnesium, and goes all the way down. Groups 3 through 12 aren't important. Like, they're just called transition metals. You don't really have to know that much about them. Group 13 starts with boron. Group 14 starts with carbon. 15 starts with nitrogen, and 16 starts with oxygen. These are just like nonmetals and like gases and stuff. And below them, they're just like other metals. This part of the periodic table, like this little yellow staircase here, you don't really have to know about them. They're rare earth metals. There's really not much to them. When we do combining elements and stuff, you might not see them. They're more of like an advanced thing. Like, they're called metalloids, and they have like different charges. You don't really have to know that. Group 17 starts with fluorine, and it's called the halogens, this little green column here, close to the right. And then the last group, group 18, starts with helium, and these are the noble gases. They're very important, and they're always, quote, happy, which I'll teach you guys about in the next lesson. But each one of these groups has their own like characteristics. We'll be learning about those later in the periodic trends topic, but each group is very special. Here are the names again, if you need to see them. Alkaline metals, alkaline earth metals, I forgot that. Transition metals, metalloids and nonmetals, halogens and noble gases. This is all you have to know for now. And having a periodic table at home is heavily recommended, like a physical one that you can write on, like label. And if you need a good one, I'll send you a link for a good one, because there's some that like contain charges and like all the stuff that we'll need for later. But okay, this is the last thing we'll be learning about today, numbers. There's a few parts to this, but I just want you guys to be comfortable with like exponents and scientific notation. I'm assuming you guys already know how to do these. Like, exponents are like squared, cubes to the power of 4, 5, 6, 7, whatever. And anything to the power of 0 is 1. You guys probably know this. This is like, I don't know, 7th grade math. You guys should also be comfortable with scientific notation, like 9.45 times 10 to the 8th power. That stands for like 945,000,000,000,000,000. I don't know, something like that. And then if it's a negative exponent, for scientific notation, you should know how to do that too. It just goes smaller. And then note that scientific notation can be written in another way too. I won't write it this way on like tests and stuff, but it'll be useful to know, because when you use your calculators, it'll say E, and that's basically a substitute for times 10. So like 9.45 times 10 to the 8th is basically 9.45 E8. You guys can have a calculator and like test it out right now. Also, if you don't have like a TI-84 calculator or something like that, I strongly recommend you get one, because that'll be very helpful. Because we're going to be looking at some very big or very small numbers in this course, and having a calculator like that will definitely help with like the calculations you're going to be doing and like conversions and stuff. So if you're all good with this, we can move on to the next part of numbers. This is the part that, wait, let me close my window real quick. Okay, this is the part that like most of my friends hated doing. This is what I heard is like the most annoying part of chemistry. It depends on your teacher really, because some people just aren't strict about it, and some people make sure that you have like very precise answers. So significant figures, also known as sig figs, there's a few rules to them where non-zero digits are always significant, which is, in case you didn't know, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are all non-zero digits, and yeah, they're always significant. Any zeros between two significant digits are significant. Like 101, that zero would be significant because it's between ones, and ones are significant. Leading zeros are not significant. Like in 0.2, that zero doesn't count. And trailing zeros aren't significant unless there's a decimal point. So like 1.0 would mean that the zero is significant. So you're going to be counting how many significant numbers there are. I already put the answers in the bottom, but just look through this. Like in 45, both numbers are significant, so there's two sig figs, because the 4 is a non-zero and the 5 is a non-zero. In 2.0, both numbers are significant, so there's two significant numbers, because the 0 is trailing, but there's a decimal point, so that means it's significant. And the 2 is a non-zero, so it's significant. 0.345, this 0 is a leading zero, therefore it's not significant. But the other three numbers are non-zero numbers, so they are significant. I don't know if this is probably very confusing or frustrating. It's not like the regular math, rounding, whatever that we do. You guys can look at the rest of these examples here. I just want you guys to get familiar with this because in future chemistry lessons are based on different teachers. These significant figures might matter more to them. I also linked a study guide down here for significant figures. It's like a little worksheet that you can do. It's really good for practice because I really want you guys to like get familiar with these and like know how to count them and add and multiply with them, which I will teach you guys next lesson. I don't know why my siblings are here. Anyways, here's the homework that I'm gonna assign you. Well, of course it's optional. It's just for practice. I just want you guys to familiarize yourselves with the periodic table more. Like just look at it a few times and like locate some of the major elements like oxygen, carbon, nitrogen, helium, all that good stuff. And then I want you guys to get to know your sig figs and scientific notation. I have the sig fig worksheet link right there. I'll put it on Google Classroom. You guys can access the slide and like click the link. Go ahead and do that. The answers should be attached too. If you guys took notes, that's great. You guys are the best. Even if you didn't, that's cool too. But like, you should read over the notes or just read over these slides a few times for the next lesson, because that's a really good refresher. And you can feel free to ask me anything. I'm free all day, every day, whatever. Yeah. And if you have any questions or feedback for me, there's my phone number, there's my Snapchat, and there's my email. If you're going to text me, please state your name and your course, because I teach more than one, and then say whatever you want to say. I'm not that formal of a texter, so you don't have to act formal either. You can just say whatever you want. And then if you want to text me and set up an extra meeting because I might have not like explained something well enough, you can just text me, and then we can like FaceTime or something, and I'll explain it to you like to the best of my ability. And if that doesn't work, I'll try a different method of explaining to you because I want to make sure that you get it because that's the whole point of this course, to make sure that you understand chemistry and that you're comfortable with it. Um, but like don't be afraid to ask me for help. Like I won't judge and it's all cool. So thank you so much for enrolling and showing up today. Um, I would be very happy if you show up for the next lesson. And yeah, thank you.